Sometimes when you're solving a system, you don't just get one solution, you get an infinite number of solutions. And so this video is meant to help you identify when that occurs. And we're going to let the calculator do all the work so that we don't have to put this augmented matrix in reduce row echelon form. We're just going to let the calculator do that. So I'm just going to go to my calculator to show you that I've already put in the matrix, this one here in red. I've already put that in. And so now I'm going to go to the quit screen, and I'm going to go back to the matrix option. I'm going to go over to math, and I go down to RREF. It's down after the numbers, you get down to B. RREF. And then I'm going to call matrix A, insert it, and then I get this. So that's nice. The calculator did all the work for me. And so I get this in reduced row echelon form. And so this is kind of interesting. I've got a whole row of zeros at the bottom. So let's write this out now. Right, this is the x column, the y, and the z, and these are my answers. So this codes to 1x plus 3z is equal to 5, and 1y minus 2z is equal to negative 2. So at this point, we might want to consider, what could we do here? If we thought we could solve this even more, maybe we could try to eliminate the z's, right? But if you try to eliminate the z's, take a look what will happen. You're just going to add the two equations. You could eliminate the z's, but then you're just going to have a new equation that has an x and a y in it. In other words, the whole point of eliminating is to get rid of one variable so that there's only one left. But if we get rid of the z, we'll just add it. We'll come up with a new equation that still has two variables. So there's nothing more we can do right now. And what that means is that this is our answer. We're sort of staring at our answer here. In the matrix here, you'll notice that the z, right, the z entry, where that should have been a 1, it got eliminated. And that means that z can be anything you want it to be. So, for instance, if I solve this top equation for x, it becomes x equals 5 minus 3z. And if I solve this one for y, it becomes y equals negative 2 plus 2z. And so x and y are completely determined by whatever I choose for z. So if z is 1, let's just go over here. If z, or let's say z is 0. If z is 0, then if I plug it into my x equation, I get x is 5, and then I get y is negative 2. So there's one solution, right, if z is 0. If z is 1, then I'm plugging into my two red equations over there. I get x is 5 minus 3 times 1, which is 2. And y is negative 2 plus 2 times 1, which is 0. Forgot to put y equals here. So that's another solution. So there's an infinite number of solutions. So the point is, the answers are x equals this, y equals this, and z equals whatever you want it to be. And that produces an infinite number of solutions. An infinite number of solutions. So what does it mean graphically to have an infinite number of solutions occur? On the next slide, I'm going to show you what it means. Remember, when you have an equation that has three variables in it, x, y, and z, then you're looking at the graph of a plane. And so when you're solving the system, you're finding where these three planes intersect. So what does it mean for the planes to intersect at an infinite number of points? The picture on the next page, I think, will sort of reveal what it means. So here we can see, in this bottom right case, we have our three planes intersecting, and the way that they're intersecting is they're intersecting on this line. See how this line is like, this line is sort of, this vertical line is where the yellow, the green, and the blue plane intersect. That's what happens when you have an infinite number of solutions. So on the last page, our system, those three planes are interacting in this special way. And all these points on that line are solutions. They're all points where the three planes intersect. So hopefully that gives you a sense of how to identify when there's an infinite number of solutions. It occurs when you can't eliminate any more variables, or one of the variables drops out as sort of insignificant, meaning we can let it be whatever we want it to be, as z was in the previous case.